Assalamualaikum, greetings. I am Dr. Ahmad FATEH bin Muhammad Noor, the supervisor in this project.
What is energy? Energy is essential to modern life because it powers houses, business, transportation, and electronic devices. By understanding the energy consumption, some issues can prevent, which are resource management, sustainability, and environmental effects. Energy consumption in Malaysia is growing due to the increasing population. The suitable grid system management, all the consumers can get the sufficient supply of the electricity. Malaysia is one of the countries that had the most stable grid. One of the factors to achieve the stability of the integrated grid is renewable energy sources. Integration of electric vehicles, distribution generation, and energy storage system make the power system studies become more vital. At the end of these studies, it will show the effect of the power system based on 3 integration above.
Next, the objective of this project. The first one, to perform modeling and simulating distribution network with electrical vehicle and distributed generation using MATLAB Simulink. Number 2, to evaluate the impacts of electrical vehicle and distributed generation on distribution network. And lastly, to analyze appropriate mitigations measures to enhance grid reliability and efficiency.
For the problem statement, the primary objective of this power system analysis project is to assess the impact of integrating distributed generation in the form of rooftop solar PV and electric vehicles into a low voltage network. The analysis will focus on voltage variations and thermal loading, specifically considering cables and transformers, to understand the consequences of DG and EV integration. One crucial outcome will be determining a safe level of EV penetration, ensuring that the network remains within prescribed voltage and thermal limits. Our analysis will identify the critical feeder within the distribution network, providing insights into areas that may require targeted enhancements for optimal DG and EV integration. To sustain DG, an energy storage system, which is ESS, will be employed as a solution, efficiently controlling power and acting as a storage device to manage sporadic renewable energy production. Exploration of various ESS options, considering technology, location, will be crucial in offering effective solutions for sustainable energy storage. The analysis will extend to exploring ways to enhance the network's capacity to accommodate electric vehicles, ensuring a seamless integration that aligns with technical and legal standards. The goal is to optimize the operation of the LV network, balancing the integration of EVs and DG while adhering to technical and legal standards for safe and effective energy distribution.
Alright, so this is our utility grid that we have been designed using 3-phase system. So this is the 3-phase source, and this is the transformer which has been regulated according to the specification, which is 11 kV and 0.4 kV. We already add the grounding system for the low voltage distribution network. So along the transmission line, we connect the feeder, which represent the load flow bus, and the total we have the 5 feeder loads. So which is the feeder A, feeder B, feeder C, feeder D, and feeder E. So along with the connection from the transmission line, we connect the load flow bus, the feeder, according to the length given, which is for the feeder A 0.1 km. For the feeder A, we have 10 residential load which has been connected at the feeder A. The same step repeated, which we connect all the loads at the feeder according to the length of cable given in the regulation, and generally this is our system for the low voltage distribution network that we have been designed using 3-phase system. So for the feeder A, which we has 10 load, feeder B we has 9 loads, same with the feeder C, 9 loads, feeder D 7 loads, and feeder E 12 loads.
The result is displayed based on a 3-phase system. Then I will analyze the voltage and current for each phase. As a task given, feeder A supply power to 10 houses. So as we can see in this picture, row 1 indicate as phase A, row 2 as phase B, and row 3 as a phase C. So I will insert the voltage and current value into the formula. Then I will sum up all the value phase by phase. Let me present the result in table. So when I sum up all the value in phase A, the total is 0.2183. So next, repeat the same calculation for all feeders. So what I can analyze that the feeder which has more load, such as feeder E, will have a higher value of impedance. Based on the display output for feeder loading, there are several factors that can be analyzed because the voltage and current produce the different values. In theory, each phase should carry the same amount of voltage and current and indicate as a symmetrical system. The first point is the voltage drop has impact these imbalance loads. As in the previous example, feeder E indicate higher impedance because the phase with higher current can experience the greater voltage drop. Another factor is the variation in cable length. When the load demand increase, the length of the feeder has to be extended, and it will resulting in more losses and greater voltage drop.
This is our PV array grid that we have been designed in order to lessen or minimize the dependency of the 3-phase source at the utility grid. So for this design, it will display several parameters, which is the irradiance, which represent the sun, the temperature, the power and the voltage, and also current for the grid, the parameter, the power, VDC for the PV array. So this design will using the converter, which using boost converter for the system in order to step up the voltage for the utility grid.
Next, after install solar PV to power grid, the active power that can produce from the power grid is equal to 1.06 kilowatt, while the solar array produce the active power from the sun power equal to 82.26 kilowatt. Next, here are also the display output after install a solar PV to power grid.
Okay, for the EV charging profile modeling, we choose type of EV in Malaysia, which is the Mercedes-Benz EQA 250 AMG line, and that is the capacity of the battery and the characteristic. Okay, for the EV, electricity is used to recharge EV batteries utilizing electric vehicle chargers, which include DC fast chargers and level 1 with level 2 chargers. DC fast chargers are the most rapid chargers available, making them indispensable for swiftly recharging electric vehicles, easing concerns about running out of gas, and fostering convenience, all of which help increase EV's acceptability. DC fast charging is an essential part of the infrastructure for EV charging, since it can reach 80% battery capacity in 15 to 45 minutes, depending on the voltage capacity of the vehicles. Level 2 EV chargers are better suited for home installations, since they use AC power at 208 to 240 volts to provide quicker charging speeds, meeting the needs of EV drivers who commute daily. And from a distribution standpoint, assessing the dependability of EV charging services is crucial to promote the development of sustainable charging stations and accelerate EV sales in the automobile sector. Level 2 chargers are widely recognized for their versatility, effectiveness, and ease of use. They may be employed in various contexts, facilitating the widespread adoption of electric vehicles and satisfying the unique requirements of different user groups. And since electric vehicles fueled by fossil fuels may emit indirect emissions when charging, it is essential to balance reducing carbon emissions with renewable energy sources to provide sustainable electric mobility.
So next, this is the example model smart home from recent papers. The EV batteries are changed and domestic appliances are energized by the electrical power generated by the utility, battery energy storage system, BESS, fuel cell, wind and photovoltaic cell. The bidirectional power flow between the utility and the smart home is taken into consideration in this work. As a result, the smart home can export extra power to the utility and buy electricity from them when needed. Furthermore, an energy storage system known as used to charge an energy storage system or device, and it is used to generate electricity at the appropriate quantities and quality when needed. So by using the energy storage system in electrical generation, it will give a lot of benefit to the electrical power industry and consumers. So next, this is the benefit by using energy storage system. So firstly is enhancing reliability and quality while balancing supply and demand on the grid. By using the energy storage, it will assist in balancing the supply and demand for power. Next, placing aside an investment in power infrastructure. The strategically placed energy storage system ESS, it can assist utilities in managing the increasing demand for electricity at a lower cost and then updating or expanding the electric grid infrastructure.
So, the conclusion of this project is the study revealed potential challenge associated with voltage imbalance and thermal limit in the distribution network, particularly in the integration of technology like electrical vehicle and distributed generation, including at rooftop of solar PV. Through power system study, critical feeder within the distribution network were identified. Understanding this critical point is essential for developing target strategies to enhance network efficiency. Other than that, the result of underscore the importance of implementing mitigation measures to address voltage imbalance and thermal constraints. Its proactive measures are crucial for ensuring the safe and efficient integration of emerging technology.